Hello. So, am I audible? Hello. Can you hear me? Hello. Am I audible?
Hello, sir.
Okay. So, see that is my screen visible or not?
Yes, sir.
Okay. So today we are going to start from the concept that is the CPU scheduling. Okay. Or you can say process scheduling. This is one function of the operating system. Now, what is the objective of this scheduling is that if we can go for the multi-programming, that means multi-programming, that means that multiple programs can be executed by using one CPU, so that the CPU can be utilized in maximum. Okay, so maximum CPU utilization is possible through multi-programming. Okay. Now several processes are there in the memory, so they are stored there, and the CPU will take the processes from the memory and it will execute one by one. Okay. So every time a process is in running state, okay, if the process is going to take input or it is going to provide some output, at that time it has to wait. Okay. So any other process can get the CPU only when the current process has finished its working. Okay. So a process has to wait for the another process. When the another process is using the CPU, at that time the process has to wait there for its running. Okay. And there is some technique, that is the CPU, suppose we can do this thing that one process is running at a time, another process may come during the execution of the current process, that is one type of scheduling. Okay. So basically there are two different types of scheduling. One is the preemptive scheduling and the other one is the non-preemptive scheduling. Okay. So preemptive scheduling means what? Preemptive scheduling means that once the process is getting the CPU for its execution, then during the execution of the process may leave CPU. Okay. That means the CPU may take any other process for the execution. Okay. That is preemptive scheduling. And if it is non-preemptive, that means when the CPU get a particular process, at that time, until the current process finishes, okay, until the current process finishes, no other process will be allowed to execute in the CPU, and that is the non-preemptive version of scheduling. Okay. Now there is two different thing. One is the CPU time burst and the other one is the IO time burst. So time burst means what? Means the time taken for the process to execute in the CPU. That is the CPU time burst. Okay. So we can divide the process execution into two different things. One is the CPU time and the other one is the IO time. CPU time means that the actual process time, process execution time, that is the process will be executed by the CPU. So CPU time means the time taken by the CPU to execute that particular process. Okay. And IO time means this may happen that during the execution of the process, any IO request is there. Suppose any input should be taken from the user or output will be provided to the user, and at that time the CPU has to wait. Okay, that means the process will go to the waiting state. Okay, and once again after the IO completion, then the process will come from waiting state to the ready state, and then again from ready state to the running state. So in this way the process cycle goes on. Okay, in a process, when the process comes, means when the process is actually bonds, that state is called the new state. That means the process just came, or that is just created. Then when it is going to be ready for execution, then it is the ready state, and in the ready queue the processes will be waiting for the execution. And when the CPU take a particular process for execution, then that state is called the running state. Then we have the waiting state. Waiting state means that any process may wait for input or output. Okay, that means getting input or providing output. If that thing happens, then that is the waiting state. And finally, the terminated state. Terminated means that the process has finished its entire CPU burst time and it is going to the going to end the process. Okay, that means the terminate the process. Okay, so that is the last state. So there are basically 5 states for a particular process, and in some books or some places you can see many 2 other process. Okay, so that is another thing, but basically the concept is that there are basically 5 states. Okay, that is new, ready, running, waiting, terminated. Okay, so any process that is actually taken by the CPU, that may either go for CPU burst or IO burst. Okay, CPU burst means that the process is executing in the part, that is the part of the execution time. Okay, that is the CPU burst. Okay, so the process has some execution time, some job to be executed, and that will be done by the CPU. Okay, and when the process is requesting for some input to be taken or output to be provided, then that will be the IO burst. Okay, that is done by using there is a CPU part and the IO part that is possible. So actually CPU part is actually telling is actually going for the execution part, as IO part is actually for the input and output. So so these things are done here one by one. Means you can either load some data, you can read file from there, either you can wait for input output, you can store something or write something there, again you can load something or read, then you can wait for input or output, then again you are waiting for the write, etc. So one by one CPU burst and IO burst are actually going to be executed. So this is the histogram that is showing actually the CPU burst and the that is having a frequency curve. So it is showing the CPU burst that is having a CPU frequency curve to the exponential curve.